Hey everybody, sorry if this mic quality is bad. This is Nicholas Bremer, and there's a washing machine also going on to my right, but the reason I'm also quiet is because there's people sleeping. But anyway, I thought of starting this new kind of series where people can kind of learn alongside me. Hopefully this helps. Basically, I want to kind of teach what I'm learning in school, essentially. Learning what I'm learning in school, what I learn elsewhere. Anyway, let's get started. Disclaimer, I should have started doing this years ago. Yeah, like when I first started undergrad, really, was probably when I should have started recording these videos. But right now I'm in my last year of undergrad, which is actually my third year. I'm going into my first year of vet school next semester, and a little nervous. I was in the early admission program, or I am in the early admission program at OSU. I've got finals next week, and yeah, I just figured I'd start doing this because, well, I'll probably come up to it later. But so I'm gonna be talking about pre-vet stuff in this video, but eventually there'll be vet school stuff. So things relating to animals, nutrition, pharmacology, all sorts of stuff relating to animals. Basically, whatever I learned that day. And this will probably be an everyday thing if I can keep it going. If I don't get too stacked up, hopefully. And yeah, other things I learned, especially like on Sundays, I'll do some church stuff. This is self-explanatory. I don't want to like plagiarize. I mean, this is just what I learned. It's how I've interpreted their information. I'm not really using their information in my slides though. So again, I'm not going to share their materials. You can probably tell that one. And yeah, there's going to be stuff I miss in the subject. I'll try and cover it later in another video. If you guys have questions, please ask, and I'll research and answer. I'll make a video about it. I'm happy to do this. I want to educate. I think with this series, my purpose is definitely to educate. My goal, again, what I was saying earlier was my first goal is, well, I guess my first goal with this is to help people learn, but another goal is I'm doing this so that I can retain what I'm learning in class. This is basically I'm going over my notes again, reinforcing what I've learned. I think this will be beneficial. So anyway, yeah, there's going to be different sections according to which class I was in at that time. So this is not a class, but first of all, some miscellaneous things I learned. Miscellaneous. First of all, a full-sized mattress doesn't fit into a Nissan Rogue. I found that out the hard way. So don't try it. Second, it may not be a good idea to go into something that can be profitable with profit being your sole intention. I'll kind of talk about this for a bit. I'll just be honest with y'all, one of the things that inspired me to do this was I'm broke. I'm a college student. I'm a broke college student. Once I'm in vet school, I'm not going to be able to work a job really. And I was like, YouTube, maybe it'll be a stream of income, you know? I mean, but here's the thing. If you go into something just with only money on your mind, money is the reason you're doing it, and that's not a good foundation. For example, if you get a job just because it pays well, how do you know you're gonna like the job? Like if if I just want to be a carpenter because it pays well, what if I don't like carpentry? What if I hate carpentry? Then you're just going to be miserable. I kind of wanted to do this. I've always wanted to tutor people. I've always wanted to kind of help people learn, and so that's why I'm doing this. Maybe if this takes off, then yes, I will be profiting from it. But still, the first goal is to help people learn. I really do want to help people learn. I want to establish connections with people watching this. If you want to leave a comment, feel free to help people. I want to answer questions. I don't know much right now, especially about vet school. I'm not even in vet school yet at the time of this video. But so animal reprod, that's one of the undergraduate classes I'm in right now, almost over. And taking my final on Monday. Today is Friday. And well, so yes, this is going to be, we're going to be talking about genitalia a little bit, not too much in this video at least. We're going to be talking more about sperm cells, but yeah, YouTube's probably going to flag this. If they do, that's whatever. I mean, it's, I know the intention I was making this with. It's not meant to be inappropriate. So, bull spermatogenesis, which means creation of the sperm, takes 61 days. These are just random facts. We kind of did a review session today. Androstenedione, which is a, well, okay, so testosterone is a steroid, and androstenedione is also kind of a steroid. It is a precursor to testosterone, which means it makes, or it's involved in the creation of testosterone. You need androstenedione to make testosterone. Next, spermiogenesis in the bull takes 17 days. I still don't exactly know what the difference between spermatogenesis and spermiogenesis is, but if anyone else knows, let me know. I might research it by the time I post this video. I don't know. I'm just making this to reinforce my notes, basically, and maybe encourage other people to learn. Meiosis 1, or meiosis, however you say that, depending on the professor, in the bull takes 21 days. Meiosis is different from mitosis. Mitosis is basically an infinite cell division. Meiosis basically only happens in fertilization between the egg and the sperm. And the function of seminal fluid is to reverse conditions of the cauda epididymis, which is the sperm storage area. The cauda epididymis is part of the epididymis. There are two other parts of the epididymis, technically three, I guess, depending on how you break up the caput epididymis. You've got the distal and proximal caput epididymis, which are the caput, the cap of the testes. And then you've got the corpus, which is the part that runs down the testes, and you've got the cauda, which is the part on the bottom of the testes. Then the vas deferens goes up around the testes. I don't know. Imagine like a 3D image here. You've got the epididymis, and here's the cauda, and then you've got the vas deferens, which goes back up. That's basically how sperm transports. Sperm is made first in the seminiferous tubules in the testes, and then essentially it goes through the epididymis, and it picks up fertilization factors in the caput. Give me a second here. It picks up decapacitation factors in the corpus. Decapacitation meaning it basically has this armor that protects it from the hostile environment in the vagina / female reproductive tract, because the female reproductive tract has got to keep out harmful bacteria and stuff, right? So in order to do that, it's got certain kinds of mucus, it's got pH changes, right? And the capacitation of the sperm is basically the armor plating. Now, decapacitation means once it gets to where it needs to go, it can take off that armor in order to be able to fertilize the egg. If it doesn't take off the armor, it can't fertilize the egg. Anyway, and then you've got the cauda, which adds motility factors, specifically forward motility factors, because you can have a sperm that's motile in a circle, but it's not going to go anywhere important. It's just going to go in a circle until it dies, runs out of energy. We need it to go straight. We need it to go forward toward the egg, or else fertilization does not occur. So therefore, it's not considered. It wouldn't be considered a viable sperm, really, I think. Okay, this is more. The number of days of spermatogenesis differs due to mitosis differences in animals. So, say you've got a pig, right? And then you've got a cow. Well, the time that it takes for the sperm to undergo mitosis correlates to the time it takes for spermatogenesis to occur. Because, I don't know, I'm not really recalling every part, but mitosis isn't all that happens to that sperm, because the sperm undergoes mitosis, then it undergoes meiosis. I don't know. I might just need to research that a little bit more, but anyway. Aspirin and dexamethasone affect COX-1 and 2. What does this mean? This is just gibberish, right? Well, what is COX? Cyclooxygenase 1 and 2. So, okay, if you are pregnant, let's just say you are pregnant. I'll talk about the cow and then the human in this scenario. If you give a pregnant cow dexamethasone, at least a significant amount, they will abort their fetus. Why? Well, I need to research a little bit more, but the gist is that, okay, we've got four, there's four molecules, okay, four. ACTH, which is adrenocorticotropic hormone, oxytocin, which is like the love hormone. There is prostaglandin F2 alpha, and then we've got dexamethasone. All four of these can induce parturition. Now, inducing parturition, first of all, we need to know what parturition is. Parturition is giving birth, basically. If you induce parturition before the fetus or baby is done developing, it's an abortion because it can't live on its own and it's now outside of the womb, right? So basically, if you take dexamethasone, so these are steroid shots, or even aspirin, while you're pregnant, it's not good. You just got to be careful with these drugs. Anyway, my nose is so itchy, I'm so sorry. Okay, it takes 14 days for bull sperm to travel through the epididymis. And I'll note that it's not the same for the different species. The range is 9 to 14 days. Some species less than 14, and then the bull 14. Takes 2 to 4 hours for the LH surge in the bovine due to GnRH, gonadotropin releasing hormone. Testosterone is made by Leydig cells in the testes, in the seminiferous tubules to be more precise. Hope I'm right about that. Correct me if I'm wrong in the comments. Adenohypophysis is just another word for the anterior pituitary. The pineal gland makes melatonin, and melatonin is a sleep hormone. It makes you sleepy. When it gets dark outside, your pineal gland makes more melatonin the darker it is, basically, I think. The neurohypophysis is the posterior pituitary. It's just another word for it. And yeah, that's all for my animal reproduction. Now, on to animal biology. What I learned today is that basically plant materials are harder to digest. You've got to have a more complex digestive system to digest them. You need, well, okay, look at a ruminant. They've got a rumen, that's why they're called ruminants. They've got a reticulum, they've got an omasum, they've got an abomasum. What do we have? Whereas they have a 4-chambered stomach, we just have a stomach. 1 chamber, right? So like I just said, they've got the rumen, the reticulum, the omasum, the abomasum. The rumen is full of microbes to digest the fiber. Okay, so you've got different kinds of carbohydrates in what ruminants eat. So if ruminants eat starch, that is not fiber. Starch is just strings of alpha D glucose, if I recall correctly. And alpha D glucose, mammals have enzymes to break down. Now beta D glucose, I think is what it was, is what makes up strings of cellulose, which is what makes up plant walls. This is what makes up fiber. Now the reticulum, basically that's, from what I can tell from the notes and from what he was lecturing, that's what helps them regurgitate and chew their cud. The omasum allows for mechanical digestion, and the abomasum is basically like our stomach. It's enzymatic digestion and pepsin and stuff like that. Now, non-ruminant herbivores, so these are herbivores that don't have a rumen, horses, rabbits, they just have a long cecum. They've got capacity to pack in fiber into that cecum in order to allow for bacterial fermentation to occur, kind of like in a rumen. However, it's past the point of primary absorption. What that means is they are going to have to eat their poop. It's called caprophagy if they want to absorb those nutrients. That's just natural, though. I mean, I imagine it's kind of gross, but their poop probably tastes good to them. It's just something to think about, because it's got nutrients in it. Good nutrients that they need. Anyway, metanephric kidney. We've got mammals have metanephric kidneys, which filter waste and water out of the blood, concentrate urea in the urine. And mammals are endothermic. They're warm-blooded, and therefore they've got more mitochondria per cell. And this was kind of cool. I found this interesting. Bigger animals use relatively less energy than smaller animals. So if you think of a fly or a hummingbird, hummingbirds got to eat all the time. You know, they're always drinking nectar. Versus elephants, they're giant, yeah, and they do eat a lot, but per unit body weight, they don't eat as much as hummingbirds. Finally, this is kind of my last slide here. Mammals have lungs, big brains, external ears, complex communication, and estrus. They've got like an estrus cycle and stuff like that. So, I mean, you can kind of think about this. Mammals, we are mammals, humans. We're pretty much the smartest organism in the world right now, at least. I mean, as far as I know. And we were made in the image of God, so it makes sense. Yeah, so yeah, these are my notes. So I don't know if this helped you guys. Let me know. If not, also let me know. If you guys want me to make more, let me know. If you guys have any ideas of what I can make, let me know. That's why there's comments down below. So thanks for watching, and I'll see y'all in the next one.